Allenes, cumulenes, spiranes. In them, optical and geometrical isomerism. Allenes, cumulenes, spiranes, optical geometrical isomerisms. See here, allene means this is allene. Consecutive two double bonds are there. So we can represent this further in this way. This with dotted bonds like this. Means up to this in one plane. And this is in other perpendicular plane. Why? Because if in this pi bond, if px utilized, px pi bond, then obviously this pi bond will be of py and py. From this carbon, px already utilized, another one py only will be utilized, being x and y perpendicular to each other. X and y perpendicular to each other. So that perpendicular planes are there whenever in this way double bond there. Two double bonds. Then cumulenes you see. So more than 2. So for example 3 I took. Now in this case, you see, here px pi bond utilized, then this carbon px already utilized, then another pi orbital definitely from py pi bond utilized. Then what about this? From this carbon already py utilized, then px only left. So here the pi bond is of px. Means xx. So will be in same plane. Or all these groups in same plane. So the terminal hydrogens are in same plane. Here the terminal hydrogens are in different planes, perpendicular planes. And like this, more double bonds consecutively present. It is cumulene. Because of this reason only, if same plane present, comparison of geometrical isomerism will come. Chance of geometrical isomerism. If opposite planes are there or perpendicular planes are there, different planes, there is chance of optical isomerism. That point we will see now. Now, spiranes means consecutive rings are there with spirocarbon. This carbon is quaternary carbon, which is spirocarbon. Two rings are joined. So these groups, and if more rings are there, three rings are there. So consecutively, 3 rings, odd number. Consecutively, 2 rings, even number. Here, n equal to 2 consecutive double bonds, even number. Here consecutively 3 double bonds, odd number. Based on this, we will have explanation about geometrical and optical isomerism. You see. Number of consecutive double bonds or rings are both together. Number of consecutive double bonds or rings are both together if present in two choices, odd number, another one even number. Number of consecutive double bonds or consecutive rings or consecutive double bonds along with rings both together. If present in odd number, chance of geometrical isomerism. If present in even number, chance of optical isomerism. Optical isomerism, geometrical isomerism if present in odd number. This is the point, provided different groups at the ends. Provided different groups at the ends. This is must. This is the basic point to find out whether there is optical isomerism or not, or geometrical isomerism present or not in spiranes, allenes, cumulenes. Consecutive double bonds or rings are both. Next, you see the examples. Now you see consecutive double bonds, n value 2, even number, chance of optical isomerism, but two different groups are there or not? HCl, two different. Okay, this side HCl, two different groups. Okay, both the sides two different groups are there with consecutive double bonds in even number. Then there is a chance of optical isomerism. So there is optical isomerism present. Now what about this? N value consecutive double bonds, 3 members are there. 3 is odd number, so that, and two different groups at the ends. No doubt this can exhibit geometrical isomerism but not Optical isomerism, but not optical isomerism. Then here consecutive rings 2 are there, even number. Then at the ends 2 different groups present or not. Once you see methyl group is there, means another one hydrogen also present, no? Carbon having 4 bonds. The fourth bond, which is not directly appearing here, is actually another one. Fourth one is hydrogen here. Here also hydrogen. Okay, 2 different or not? Hydrogen and methyl, different. Hydrogen and methyl. So both ends having 2 different groups with n is equal to 2 even number consecutive rings. So this is having chance of optical isomerism, optically active. And what about this? N value 3, odd number. 2 different groups are there or not? Methyl and hydrogen. So odd number, so that exhibiting geometrical isomerism. A few more examples we will see to get more clarity. Now here we need to decide what kind of isomerism is there. Double bond, ring, double bond. I said both together also. Consecutive double bonds, rings are both together. So two double bonds and one ring. Total number 3 consecutive means odd number. So it is exhibiting geometrical isomerism. Here also double bonds, rings together there. 1, 2, 3, 4, 5. 3 rings, 2 double bonds. Total 5. Again, this is odd number exhibiting geometrical isomerism. We need to cross check whether different groups there are not at the ends. Methyl and hydrogen. 2 different, so no problem in the sentence. Methyl chlorine different, COH, C2H5 different. If same there, then that cannot having geometrical isomerism or optical isomerism. In these cases, one geometrical isomerism there means no optical isomerism. Now in this case, 1, 2, 3, 4 consecutive 4 rings are there. Chance of, and 2 different groups there are not, we have to cross check. Yes, complete all 4 groups are different, even number, then exhibiting optical isomerism. Now here Consecutive double bonds, how many? 1, 2, 3, 4. An even number. Sorry, even number means we'll have optical isomerism. No? So, two different groups there are not. One is chlorine, another one hydrogen. For this carbon, two different. For this carbon, one is hydrogen, another one methyl, two different groups. So, optical isomerism can be exhibited by it. In this way, we need to solve. If two different similar groups are there, that cannot exhibit. Say for example, in this way there are CH2, CHCl being two similar groups, no optical isomerism, no optical isomerism. Similarly, ClCH, double bond, C double bond, C double bond, C, 3 double bonds there, but H2 there, 3 consecutive double bonds there, but H2. So, similar groups there, no geometrical isomerism. In this optical isomerism also not there, in this geometrical isomerism also not there.